Okay, good morning class. Right, so in everyone already here?
One more.
One more. Who?
Ketiga.
Ketiga. Okay. Right, so never mind. So actually for 4.2, right? For the specific latent heat, did we finish discuss all the question? Can you check for me? For the question, did I already finish discuss?
The exercise one part not yet.
Oh, okay. Wait for a while. The question not yet, right? So starting from here, is it?
Yes.
Okay. Okay, so for exercise one, right? So it says here, if 2 kg of ice melt, okay, when 452,000 joule of heat energy is supplied to it, what is the specific latent heat of ice? So yesterday we already learned this one, okay? So specific latent heat is means the amount of heat energy, right, required to change, okay, a phase, right, for to change a phase for 1 kg substance without change in temperature. Okay, so that's the meaning of the specific latent heat. So if you involve in the question involved in calculation, so what is the formula? PT is equals to ml, right? So PT is equals to ml. So I show you one example. PT is equals to ml, or sometimes you use Q is equals to ml. Okay, so this is the quantity heat energy, okay, need to change the phase for let's say solid to liquid, okay, without changing in temperature. So this is the formula, okay, and this is the formula. Let's say if there is electrical energy supplied, okay, and then the electrical energy will change to the heat energy. So this is the formula we use. Okay, but for this one, it says here if 2 kg of ice melt with 452,000 joule of heat energy is supplied to it. So you already know the mass is 2 kg, right? And then the Q here is 452,000. Okay, so this is the amount of heat, okay, or quantity of heat. So the Q is 542,000, and also it's asking you to find the specific latent heat. So it asks you to find the L here. Okay, so use the formula Q is equals to ml. Okay, so Q already given 452,000. Okay, and then the mass is 2. So what is the value of L here? Can anyone calculate for me? 226,000 J kg negative 1. 2 to 6. Okay, alright, very good, Janet. Okay, so let's see question number 2. Okay. Okay, can you try to answer first? For this one, is ask you to find the value of specific latent heat of vaporization. So they ask you to find the L here. Okay, so take out what's the info given the question first. Right, so let's say for 50 joule per second. So what is actually 50 joule per second? What is actually physical quantity for 50 joule per second? What is it actually 50 joule per second? What is the physical quantity? Okay, so this is the formula. Power is equals to work over time. Okay, work is actually must be in joule, right? Time should be in second. So joule over S. So joule JS negative 1. So actually JS negative 1 is actually equals to watt. Okay, so this one is actually 50 watt. Okay, but they use joule over second, but it's just same thing. Okay, so that one is a watt. Okay, so anyone can tell me what is the formula that you use for this one? What is the formula you calculate for this question? PT is equals to ml, right? Very good. PT is equals to ml. Okay, so try to calculate what is the value of L here. $150. Krisha got 150. Sam got 150,000. Viken and Lashmi 115,000. How you guys got so many zeros? Okay, so let's try to answer for this one. Okay, the power is 50, right? Okay, and the time is in minutes, so you have to change to second. So it should be 120 because 2 multiplied by 60. Okay, and for this one the mass is you have to change to kg because that is the SI unit, right? So 0.04, and you need to find the L here. Okay, 0.04. So that's why you get the value of L here. If 0.4 means 400 gram, right? So what is actually the value that you got here? 120 times 50 divided by 0.04, you got 150,000 joule. Kg negative 1. Okay, so correct. Alright, so question number 3. So is it? Yes. So this one actually they changed to the standard form. Okay, the next one. Remember, change to kg first. This is what? Using what formula? Actually, if you already see, they give you the watt, right? So PT is equals to ml, right? PT is equals to ml. Three 300,000 joule kg negative 1. Is it correct? Okay, so what's the formula here? PT is equals to ml. P is 50, time is 5 times 60. You have to change to second. So the mass is 0.05. L you need to find. So wait, I'm using my calculator. So 50 times 300 divided by 0.05. So you got 300 joule kg 1, 2, 3. Yes, kg negative 1. Okay, so that's the answer. Okay, very good. Okay, so how about this one? This one also use what formula? Yes, PT is equals to ml. Okay, so Kritika got 10,020 seconds. Okay, so this one also same. PT is equals to ml. P is 500. Time you need to find. Okay, so the mass here is 1.5 and the L here use 3.34 times 10 power of 6. Okay, so yeah, I got this one also 10,020 joule. Okay, so that's the answer. Okay, so if you see for this one, okay, this one is wrong because this one they use 10 power of 5. Actually, it's the 10 power of 6. Okay, so this one the answer is wrong. So you just take the value that you calculate just now. So just use your answer. Okay. All right, for number 5, okay. How long does it take? Okay, what is the time required to reduce the mass by 70 gram of water? Okay, has reached its boiling point. 316.4 second. So this one using what formula? Again, PT is equals to ml, right? Because you already see they given you the electrical energy. So all the electrical energy we use to heat, we convert to heat energy. So that heat energy we use to change the phase of the from liquid to the gas, right? So the power here is 500. So the time is you wanted to find, and the mass here is 0.07, and the L here is 2.26 times 10 power of 6. Okay, so let me calculate. 2.26 exponent 6 times 0.07. Okay, so I got 316 point, wait. Okay, so the answer is 3.16 second, right? Okay, very good. Okay, number 6. Okay, 0.4 kg of water of 330 degrees Celsius is heated until all of it converted to steam. So what is the amount of heat energy supplied to it? Okay, so this one, let's see if I have a water, right? So the water, the temperature of the water is 30 degrees. So I need to boil it, I need to heat it until all it changed to steam. Okay, so if you see the graph, right, for the heating curve for the water, right? Okay, so this is the melting point, right? 0 degrees Celsius. So this is the boiling point, right? It's at 100 degrees Celsius. So the water is, the temperature of the water is actually like around here, 30 degrees Celsius. Okay, So to increase to boil it, so it need to reach until 100 degrees Celsius. So mean it need to increase the temperature. Okay, so to increase the temperature, you need to know how much the energy that need to increase the temperature until 100 degrees Celsius. So this one we use what? MC theta. Okay, MC theta. So first part you need to calculate first the heat energy to increase until the heat energy need to increase until it reach 100 degrees Celsius. Then after that, at this part, then you can use ML. Okay, because it said all it already converted to steam. Okay, so make it until here. Okay, so the answer should be MC theta plus ML. Okay, MC theta plus ML. Do you understand how do I get this equation? How do I get MC theta plus ML? Teacher can repeat. Okay, sure. Okay, so for this one, this question is said the temperature is 30 degrees, right? Okay, so 30 degrees, if I draw a graph, 30 degrees is around here. Okay, and it said it will be heated until it converted to steam. So means steam is in the gas state. Okay, so mean it will be heat until here. Okay, until all of it change to the gas. Okay, so from here 30 degrees to 100 degrees Celsius mean you have to give the heat energy for it to increase the temperature until 100 degrees Celsius. Then after it reach 100 degrees Celsius, after that then it will turn into gas or steam. Alright, so for this one 30 degrees to 100, you need to calculate the specific heat capacity. The one Q is equals to MC theta. How much does it need to increase the energy? So to increase the temperature from 30 to 100. So that one is MC theta because only MC theta that has the increase in temperature. ML doesn't increase the temperature, stay constant, right? So for this part is MC theta. Okay, so the energy need to increase from 30 is to 100 is MC theta. Okay, after that it will change to steam. Starting from here it will change to steam, right? And then until at the end here it will be completed. Okay, all with that will change to steam. So this one you need to add ML. Okay, so MC theta plus ML. So then after that you will know what is the amount energy that needed from the 30 degrees Celsius of water to change until gas. Okay, at the first part to increase first until it become 100 degrees Celsius to boil the water first. So how much does it how much the energy needed to increase the temperature? So you use MC theta. Okay, after that at ML, okay, now it started to change to gas, okay, to the steam. But they completely turn into the steam at the point here. So this one you have to use ML. So MC theta plus ML. So this one is the amount of heat energy, okay, from the 30 degrees Celsius of water to change completely to steam. Okay, is it okay, Saji? Are you really understand? Can you really understand for this one, Sajid? Okay. So now after that you can use the formula. Okay, 0.5 is the mass. C is the 4,200. Okay, how about the theta? The theta is 100 minus 30. Okay, because until here, right, the temperature change from 30 to 100 degrees Celsius, then it will start to boil. Okay, so 100 times minus 30 plus M is 0.5 because it said all complete. Okay, all of it completed change to steam. So the mass of the steam also will be 0.5. Okay, and the L is 2.26 times 10 power of 6. Okay, so what is the answer for this one? Mm. Some got 1,277,000. Some got Venus, you got 1,113. 1 million. Is it 1 million, right? 1 million? No, no. 1,130,270. Okay, so let's see which one is correct. Hmm? You're wrong. I got 1,217,000. 1277000 joule. Okay, but for this one, if you see like too many numbers here, right? So you can change to standard form. So 1.28 times 10 power of 6 joule. So can. Teacher, I keep getting 127. Eh? Really? Then where's the 7,000 goes? Wait, see the calculation here. Did you get the correct one, Risha? 7. Did you, this one, your equation is correct. Oh, why? What happened? You keep put, oh, you put here 4,000, not 4,200. Hmm. Oh. All right, for this one, it says here 2.2 kg of water at 238 degrees Celsius is heated until half of it changes to steam at 100 degrees Celsius. Okay, so how much heat energy needs to be supplied to the water? Okay, so again, that if let's see if we draw a graph here. um, Okay, so this is the melting point, right? 0 degrees Celsius. And this is the boiling point, 100 degrees Celsius. So 28 is like around here, okay? Okay, so let's say this is a 28 degrees Celsius. So it needs to change to steam. So before it changes to steam, we will need to reach the boiling point first. Okay, so from 28 to 100 degrees Celsius. So how much does energy needed from 28 to 100 degrees Celsius to increase the temperature? So for this one, we use MC theta. Okay, and starting from here, right, it started to change from liquid to gas. Okay, but it can only complete change to gas until this level. Right, so again, this one is ML. Teacher, is it okay if you can explain the graph again? How you get the MC theta plus ML? Okay. Just now I already explained. Can you understand, or you want me to explain again? Janet? Oh, sure. Don't. It's okay. Just tell me. Okay. So this is the graph, right? Okay. This is the heating curve. Okay. So for this one, this is solid. This is solid plus liquid. and this is liquid. This is liquid plus gas, and this is gas. Okay, so this one you already know the melting point is 0 degrees Celsius, and this one is the boiling point, right? Boiling point 100 degrees Celsius. Okay, so for the question just now, it said it need to boil, right? It need to boil from 28 degrees Celsius until it change completely to steam or gas, right? So 28 degrees Celsius they say is around here. Okay, so for the liquid to change to gas, it need to reach boiling point first. You have to heat first, right? They say that I give you a water, then you want to make it to change it to steam. Of course, you have to boil the water first. Okay, so for this one, it started, let's say this is the 28 degrees Celsius, the temperature of the water. So I need to increase to the 100 degrees Celsius first. Then after that, it can change to gas. Okay, so for this one, how much the energy that I need to increase from 28 to 100 degrees Celsius? So how much energy that I need? So this one you already learned yesterday, right? For this one, if you want to calculate the quantity of heat energy, this one you should choose, you should use MC theta. Okay, because MC theta is the one that heat energy that can increase the temperature. ML cannot, right? Yeah. So for this one to increase from 28 to 100, so how much energy that you need? So you use the formula MC theta. So this is the amount of energy that you need. So after it reach 100 degrees Celsius, it will start boiling. Okay, so at this point, all the liquid, not all the liquid, so the liquid will started to change to gas. Okay, at here. Okay, and this is the process, it's still process, but until here, okay, until here, at this part, all already changed to the gas. Okay, so if I want to find how much energy that I need to change the liquid to gas is on this part. Okay, so this is called as what type of heat? Specific latent of heat. So how you I want to calculate the quantity energy for the specific latent of heat? I use ml. Okay, so now I already know. Okay, if I want to if I want to change the 28 degrees degrees Celsius of water, okay, to the gas, I need to need to increase the temperature first until 100 degrees. Then after it boil, it will completely until it completely change to the gas is until here. So this one, the what is the amount of energy if I want to calculate? So I'm using MC theta here. Okay, and for this part, I'm using ML. So what is the total energy? MC theta plus ML. So are you clear, Janet? Okay, so this one is actually I calculate why MC theta, because I need to increase first the temperature. So if I want to increase the temperature, of course I need the energy. I need to give the energy to the water. So how much the energy that I need to give to the water? So this one I have to calculate MC theta until it reach boiling point. Okay, then I want to change it to the gas. So I have to give energy again to the water. So this is ml. I give the energy, then it changed to steam. So how much energy that I need? So I need to add two type of energy there, MC theta plus ml. Okay. All right. So we move on to the next one. No, you already calculate this one. So this is the answer. This one. Did you get the answer? This one. Why 1.6? Because here it said only half of it. Okay, so the mass here, the mass that changed, the mass of water that changed to solid, only 1.6, half of the initial mass. Okay, so that means inside of the beaker, there's still 1.6 of water inside of it. Only 1.6 that changed to the steam. Okay, so that's why they become 1.6, because half of it only. So 3.2 you divide by 2, so 1.6. 1.6 release as a steam, 1.6 still in the form of water. inside of the beaker. Okay, but for this one is used to increase the temperature, so the whole liquid will experience the process of boiling. So this one I have to use the mass of the water, so 3.2 times 4200, and then this one is the change of temperature, the final temperature minus the initial temperature. So everyone got this question, this answer? Anyone still didn't get the answer for this one? But I think you know, or you already know. Oh, okay. Okay, so we finish about the specific latent heat. Okay. So can I ask again? Okay, so what does it mean by specific latent heat? Let's say if I ask, what is the meaning of specific latent heat of vaporization? Can you give me the meaning of the specific latent heat of vaporization before I move on to the next one?
Heat absorbed for 1 kg substance to change from solid to liquid or vice versa at constant temperature.
Yes, very good. Very good. We can. Okay, so that's the
Wait,
answer.
teacher,
Yeah.
vaporization, right?
Yeah?
Vaporization, right,
Yeah,
teacher
yeah,
asked me.
yeah. Vaporization.
Oh, it's from liquid to gas or vice versa at constant temperature.
Yes, liquid to gas, vice versa. Okay. If fusion is solid to liquid and vice versa. Okay. So you have to know what is the question there. Sometimes if they say like specific latent of fusion for ice. So ice of course you know from solid to liquid only. So you just need to state solid to liquid. If let's say for water, okay, vaporization of water, so that means it's changed from water is liquid to gas. So you don't need to mention gas to liquid. Okay, so you have to depend on the question. So just now I just asked generally, what is the meaning of the specific latent heat of vaporization? So vaporization, gas to liquid also vaporization. Liquid to gas also we call it a vaporization also. So you have to answer vice versa. Okay. So let's see for the next one. This is the last part of chapter 4. Okay, there is a gas law. Okay, so basically there are three gas law that you need to know. Okay, the first one is the Boyle's law, okay, Charles law, and also the Precious law. Okay, so we see one by one. Okay, so the next one is said how gas pressure is produced on the wall of the container. Okay, so you have to know, right, inside of the container the molecule of gas, okay, is keep moving. Okay, so it keep moving in the random motion. Okay, and then they will hit, right, then they will hit the another molecule, and also sometimes they will hit the wall of the container elastically. So they will collide with the another molecules or the wall of the container elastically. So every time the collision occur, so that is change in momentum of the gas molecule. So every time it hit the wall, okay, every time it hit the wall there will be a change of momentum of produced. Okay, there will be a change of momentum. So the force is the rate of change of momentum. Okay, so therefore a force act on the wall of the container. Okay, so this force will create a force. Okay, this reaction, because when the molecule hit the wall container, it will produce the change in momentum. So this change of momentum produce a force. Okay, produce a force. Right. So this force that we produce a pressure, right? And they produce a pressure. So what does it mean by pressure? Pressure is is a force per unit area. So this one you already learned, okay, in form 2, I think. So therefore, the pressure of the gas due to the force of the collision of the gas molecule with the wall container, okay. So that's the cause of it. So means the pressure is produced when the molecule is collide with the wall container. Okay, so I explain again. So let's say if I have a container here. Okay, so this is the gas molecule, and the gas molecule will collide with each other, and also at the same time it will collide with the container. So when it collide with container, it will bounce back like that, right? So this is called as a elastic collision. Okay, after it hit the wall, it will bounce back. Okay, so this is the elastic collision. So every time it hits the wall, okay, it produces the change of momentum. Okay, the change of momentum, or you say impulse, right? Change of momentum is impulse, right? So when you produce the impulse there, so the impulse will produce a force. Okay, the impulse will produce the force, okay, at the wall here. Okay, so when you produce the force at the wall, so you already know, okay, the meaning of pressure is force divided by area. So whenever the force produced, there will be a pressure too. So the force, actually what caused by the force here? The force is caused by the collision, right? If there is no collision, of course there will be no change in momentum, and there is no change of momentum, that means there is no force. Okay, so actually what is the cause of the pressure is the caused by the collision of the gas to the wall container. Okay, so that's the meaning. Okay, right. So if there is no collision between the gas to the wall container, there is no pressure, right? So can you understand that one? Is it okay? All right. Okay, so let's see here. So it said to recognize variable, okay, which affect the behavior of the gas. Okay, so now let's say you have a string, okay. So you close, okay, at the end of the string there, you close it with your thumb, alright. So close the mouth of the string, and then you push the piston into the string. Okay, so you see what happened to the volume and the air pressure in the string, okay. So the volume will be decreased, right? So when you push the string here, the piston here, okay, when you use the piston here, the volume will be decreased. Okay, so when the volume will be decreased, so what happened to the collision? The collision will increase because now the space to move is very small. Okay, so they will keep hitting the wall container, okay, frequently. Okay, so let's say I explain again. You push the piston here. So now let's say if I push the piston here until it become until here, right? Right. So if I push it until here. So now you can see the space for the gas molecule now is decrease. So it will keep hitting the wall container very, very frequently. So means now the pressure is increased, because you already know the pressure is depend on the collision of the gas molecule. So if there is more collision, there is more pressure, right? So for this one, the volume is decreased and the pressure is increased. Why? Because the number of collision between the gas molecule and the wall container become increased, right? So for B, it asks here to recognize, right? To recognize two variables which affect the behavior of the gas. So for this one is the volume, right? Because I changed the volume of the container here. And the next one is the pressure, because the pressure is increased due to the decrease of volume, right? So can you understand for this one? Any question? It just seem like this one. If they say that if you take a bus, right? If you take a bus, if there's too many people in the bus, you will collide with each other, right? Okay, but they say if there is more space, okay, there is more space of you, okay, then they say you take a bus, there is not many people in there, so the number of collision also will become decreased, so it means the pressure also decrease because you got more space to move, right? So that is like as an assumption. Okay, so for this one is the volume and also the pressure. So when the volume decrease, the pressure will become increased. Why? Because there is a small space for the gas molecule to move. So mean it will keep with the it will hit the wall container. Okay, the collision will become increased. Okay, between the gas molecule and the wall container, and you already know the pressure is caused by the collision of the gas or molecule to the what container. So if there is more collision, more pressure, right? So that is the that is the explanation. So another one. So what will happen to the temperature and volume of the air? So this one you hit the air in the air test tube slowly. Okay, so here you put the water, okay, the water that has a color, okay, and then you can see it will increase, right? So it will increase. Okay, this one will move up. Okay, because of what? Because this one, okay, the gas inside of it, okay, is expand. Okay, it become expand, it will push the color water here move up, or this one is the pressure become increase, right? Because if you give the heat to the air, okay, so the air will will move faster, right? It will move faster. The kinetic energy will increase because you give heat to the water. Sorry, to the air. So if you give heat to the air, it will move faster. So we move faster means the collision also will become increased, right? So when the collision become increased, the pressure also become increased inside of this test tube. It will push the water go up. Right, so this one, what will happen to the temperature and the volume of air? So the temperature increase, the volume also increase. Right, so for this one it said what is the two variables here. So this one is for the volume and the temperature, right? So the volume and the temperature. So from the two activities above, state three variables which affect the behavior of gas. The first one is the volume, pressure, and temperature. Okay, so the characteristic of gas. Okay, so volume. Okay, for the volume of the gas is equals to the volume of the container. Right, and for the temperature, the average kinetic energy is directly proportional to the temperature. Means if the temperature increase, the kinetic energy also increase because the molecule will move faster. Okay, and then for the next one is the pressure. So the pressure is the when air molecule collide with the wall of the container, they rebounds back. Okay, there is a change of momentum and force is exerted on the wall. So this one I already explained. We already explained. Okay, and then the force per unit of area is the gas pressure. Okay, so pressure caused by the collision of the gas between the collision of the gas and the wall container. Okay, so that is the kinetic, okay, based on the kinetic theory. So how you want to explain about pressure and about the temperature. What will happen if you increase the temperature, the kinetic energy increase, it move faster, the pressure also will increase. For the pressure, right, if you keep if they see just now, right, we change the space of the space for the gas molecule to move, right? So it becomes smaller, so it will keep the collision also will increase, okay, because there is not so much space to move, so it will keep hitting the wall. So the number of collision between the wall and the gas also will become increase, and the pressure also will increase. Okay, so pressure is caused by the collision between the gas molecule and also with the wall container. Okay, now we see about the SI unit. So this is a Pascal. So what is the SI unit for it? This is a PA, the SI unit, and the other unit is CMHD. Okay, and for the volume, okay, the unit is centimeter cube, and the SI unit also is a centimeter cube, and other unit we call it sometimes a liter. Okay, for temperature is a degree Celsius, and the symbol for SI unit is degree Celsius also, and the others unit is Kelvin. Okay, so let me remind you, for the gas law, all the temperature must be changed to Kelvin. Okay, so later if the calculation question, okay, is involve the temperature, please change to Kelvin first. Okay, so how to change to Kelvin? You just need to add 273. Okay, just need to add 273. Okay, now we see the first one, the Boyle's law, right? So before that, let's see a video. Okay, so this is the Boyle's law experiment. Okay, this is actually a Borden gauge. Okay, this one is to measure the gas. Okay, so the pressure. Okay, and this one is the unit to. This one can measure the volume, right? The volume of the water here. Okay, so let's see. Okay, so this is it increase the temperature here. Okay, so when you increase the pressure here, okay, so what will happen to the volume? Okay, so volume here is actually from here to here. Don't calculate from here to here because we take the volume of gas, right? Volume of gas. Okay, so when the pressure is increased, okay, the volume also the volume will be sorry when the volume is decreased, the pressure will be increased. Okay, so this is the first experiment, but for in the lab we didn't use this one. We use the shrink. Okay, the shrink, and then we put in the rubber tube. Okay, and then we connected it to the Borden gauge. Okay, and then you see what happened when you push the shrink. Okay, you read the pressure there. Okay, so then you can see what happened during the Boyle's law. Okay, so this one later when we go to school, we can do these experiments. Okay, so let's see for we continue for this one. So state the law, Boyle's law. Okay, and then you have to draw, and then you have to explain the law by using the kinetic theory. Okay, and then you have to solve the problem and explain the experiment. Okay, so for this one is said here, so the aim here is to investigate the relationship between pressure and volume. Okay, so diagram A shows a gas with a constant mass and also temperature in the cylinder. So both have a similar mass and also same temperature. Okay, and then I put a load, okay, I put the load on the top of the piston. Okay, and diagram B, I put another load, okay, added on the piston. Okay, so actually the load is actually is a what? Is a to reduce the volume here. What is the function of the load here? Is actually to reduce the volume of the space here. Okay. So what happened to the volume of the gas? So the volume will be decreased. Okay, because I increase the load here. Okay, so the volume will be decreased. So the volume will be decreased. So based on the kinetic energy, okay, explain what happened to the gas pressure. So for this one is actually we just discussed just now. Okay, what happened when the space is small? Okay, what happened to the number of the collision there? Okay, so can you try to explain, right, what will happen to the pressure of the gas? Okay, try to do it on your own word. What will happen to the gas pressure? Anyone want to try? The pressure of the gas will increase due to the number of collision and change of momentum. Um, okay, you have to state whether the gas pressure is increased or what. When the volume decreases, the particle will collide more frequently between each other and the wall. High frequency of collision will result in high gas pressure. Okay, very good, Sajif. Okay, you need to state whether it's increase or decrease. Okay, so the gas pressure will increase since the volume decrease. The rate of collision between the particle is increased. Okay, good. Okay, good explanation. All right. So both correct. Okay. So let's say here, okay, for the volume it decrease. Okay. So when the volume is decreased, so there is not so much space for the molecule gas to move now. Okay. So if we keep collide with each other, and also if we keep collide with the wall of the container here. Okay. So this will increase, right? It will increase the rate of collision between the gas molecule and the wall container. So as you already know, the pressure is caused by the collision, right, between the wall container and the gas. So if the gas keep hitting the wall, so means the pressure also will increase. So that's the explanation. Then the gas molecule will collide and increase the force and momentum. And the high pressure due to the pollution of the gas molecule again. Okay, correct. Okay, but for me, the most accurate answer is Sajif one. Okay, Sajif one is better. Okay, but let's see if you answer this one in the exam, I accept also. If I just want to see the keyword, okay, the first one, the keyword means the rate of collision, the number of collision increase. Okay, and then the second one, the pressure increase. Okay, so that's the main point that I want. The kinetic theory states that the particle are always in random motion. When the volume is decreased, there will be a less space for the particle to be displaced. Thus, the particle will collide each other frequently. This alright. That one also good, Kritiga. Okay, so everyone give a correct answer. Okay, I just need like 2 points. Okay, so means the first point means we have to say that the frequency of the collision between the gas molecule and the wall of the container increase. Okay, then the pressure of the gas increase. So if you mention about the momentum, the change of momentum, okay, that one is for the four question mark for the essay part. Okay, for the essay part, yes, you can answer that long. Okay, we get full marks. Okay, but for this one usually only two marks. Okay, because actually this is a structure. So for the structure only 2 marks, you just need to mention that the frequency, okay, the rate of the collision of between the air molecule and the wall of container increases, okay, and the pressure also increase. Okay, so that is a 2 point. So the volume decrease, right? The gas molecule are closer each other, right? And then the rate of collision between gas molecule and the container increases, pressure increase. Okay, so this is the explanation, right? Okay, so state the relationship between the gas volume with gas pressure. So the volume is inversely proportional. So when the volume when the volume decrease just now, right? Like we push a shrink, right? And then the space becomes smaller. So what happened to the pressure? The pressure increase because the rate of collision between the wall container and the gas is increased. Okay. So this one is the relationship between the gas, right, and the pressure. Sorry, the volume and the pressure. So the volume is inversely proportional with pressure. So it should be like this. Mm, no, should be here. P is 1 over V. Okay, P is directly proportional to 1 over V. So this is the equation. Okay, so what is the Boyle's law state here? Boyle's law states the volume of gas is inversely proportional gas pressure if its mass and temperature are constant. Okay, mass and temperature are constant, the volume is inversely proportional to gas pressure. So this is the equation for Boyle's law. Okay, we already done this one. Okay, so this is the formula. Okay, from here is actually P is inversely proportional. Then I change to PV is actually equals to K, right? So this one is for one container. So let's see if I compare two, so it become P1 V1 equals to P2 V2. Okay, if I compare two container, or maybe this is after and this is before and this is after. So this is before I push the shrink, and this is after I push the shrink. So what happened? So P1 V1 equals to P2 V2. This is before, this is after. Okay, so this is the equation here. And this is the graph. So P is inversely proportional to V. So that's why the graph is like this. Okay, but P is directly proportional to 1 over V. Okay, and this is graph of PV, okay, against V. Right? So for this one, you need to remember the graph and also the equation. Okay, this one doesn't involve any change in temperature. There is no temperature involved in this one. Right? So let's see this video. See? Okay, what happened here is actually they take out the gas molecule. Okay, so they take out the gas molecule, okay, from here. So here inside the pressure is decreased. So when the pressure is decreased, so this form will expand because there is lack of pressure here. Okay, so they take out the gas molecule from the container here. Okay, so what will happen here, there is air pressure here will become decreased, right, because the lack of the molecule of gases. Okay, because it's already take out from here. Okay, so what happened to the form will expand because now the pressure here is less. Okay, so it will expand. So this is actually also the Boyle's law. So then now it put the back the oxygen inside of this. So when you put back, now the pressure is increased inside of it. So it will push down the form. Okay, it will make it smaller. Okay, because of the pressure here is high. So it explain to the right. So that's the experiment for that's not experiment. That one is actually the activity or demo, right, to prove the Boyle's law. Okay, wait. Oh my god. Okay, so this is a marshmallow. Okay, the marshmallow. So it become fluffy. So this one also, the gas pressure it will be taken out. Okay, so this one should be expand. It will be expand. Okay, right. So this is the another video. Okay. Okay, so it close the mouth of the shrimp. Right, so you can see uh the pressure here, because the space here very space is very small, right? So the collision is become higher. Okay, so that's why the building become like that. right? This is here. Okay, this is for this one. See? Ah, okay, so this one you can see the balloon size of balloon become decreased because now the pressure outside is become increased. So it will push the balloon become smaller, right? So let's see again. So this is the size of balloon. Okay, see it becomes smaller, right? Okay, because of the outside pressure is higher. Okay, this one is lower, so it will push the balloon become smaller. Then when it pull out the syringe, okay, then the balloon become bigger because the pressure of outside is decreasing, so it become bigger again. Okay, so this is actually the Boyle's law activities. Okay, to show there's a Boyle's law for the Boyle's law. Okay, so next, okay, so let's try to calculate for the calculation problem for Boyle's law. Okay, so P1 V1 is equals to P2 V2. Okay, here it said a weather balloon is filled with helium gas to a volume of 30 liters of 1 atm pressure. So the balloon is then released. Okay, as the balloon rises up to the sky, its volume increases. What is the pressure of the helium gas when the volume of the balloon increases to 120 liters? Right? So for this one, they already give you the volume is 30. Okay, what is the pressure here? 1, right? Okay, and then another one is said as the balloon rise up to the sky, its volume increase. So we don't know what is the volume, okay? But sorry, what is the pressure? So what is the pressure means they ask you to find the pressure. Okay, when the volume of the balloon increases to the 120. So volume 120, you need to find P pressure. So P2 is 30 divided by 120, right? So what's the answer for 30 divided by 120? So you will get 0.25 atm. Okay, atm means the pressure unit for the atmospheric pressure. Okay, so try for this one. Okay, this is the air bubble. Okay, for this one, anyone got the answer already?
0.25 cm cube.
0.25. Okay. What's the equation? What is the formula that you get? What's the formula that you use?
P1V1 equals P2V2.
Okay, P1V1 equals to P2V2. Okay. Can I know what your P1?
0.5.
0.5. Okay. How about your P2?
10.
10. Okay. So let's see how to answer for this one. So you have to remember, okay, inside of the water. So this is actually inside of the water. Okay. So inside of the water, there are two pressure that acting on the bubble, on the air bubble. The first one come from the atmospheric pressure. Okay, and the second one come from the water itself, right? So for, let's say I took the P1 B1 is in the water, okay, and this one at the surface of the water. Okay, so for inside the water there are pressure. Okay, so the first one is the atmospheric pressure, there is a 10. Okay, and then another one is from the water itself. So from this one is 0.5. Okay, 0.5. Okay, and the volume here is inside the water is 5 cm cube. That is the volume of the air bubble, right? Okay, so I explain again. This one 10 is come from the atmospheric pressure. So I did tell you inside of the water there are two types of pressure. The first one come from the atmospheric pressure from the outside, okay, from the outside here, and the second one come from the water itself. So you have to add two type of pressure here. Inside of the water, you have to add two type of pressure here. The first one from the atmospheric, and this one come from the water. So 0.5. Okay, and then the volume, okay, when it inside the water is a 5, right? Okay, so when it release to the surface here, so only one pressure acting on it. That is only atmospheric pressure. So what is the atmospheric pressure here is 10. Okay, so you have to find V2. So you will get 10.5 times 5, 10 V2. So can you calculate for me? 10.5 times 5 divided by 10. I got 5.25. So that's the volume. Okay, can you understand?
Yes, sure.
Yes. So others, you understand how do I get 5.25? Actually, the first thing you have to understand this one first. This one is only, this one I think you don't have a problem, right? The calculation part. Only this one at this time. How do I form this equation? Okay, because inside of the water, I already told you there are two pressure acting on the bubble. The first one is atmospheric pressure, that is a 10. Okay, and then you have to add with another pressure that is inside the water, right? So inside the water is 0.5. Okay, so it's actually 0.5 is the pressure, okay, in meter. Okay, and then you add, you got 10.5. Okay, teacher, for volume, what is the SI unit? Volume, the SI unit is cm cube. Sometimes they use meter cube also. Okay, but so you have to see the question first. So do you know do you understand how do I get this equation? Do you have any problem with this? This one. This one I know you don't have any problem because this one is only maths. Tava, do you understand how teacher get this equation? Janet, Raja, India, Lashmi, okay. Asha, Sajiv, okay. Alright, so let's move on to this one. Okay, try to answer this one also. P1 V1 equals to P2 V2. This one you have to use the atmospheric pressure 70 5 cm Hg. So it said here a small mass of gas is trapped by 3 centimeter length mercury, okay, in a small tube, right, as shown in the diagram. So then the tube is turned around so that it sits upright. Okay, so now it's asking you what is the new length of the trapped gas. So the atmospheric pressure is is the 75 cm Hg. Teacher, is the equation 75 times 3, 75 times V2? No. P1, V1, P2, V2. Okay, let me explain. Okay, for this one, okay, you know the atmospheric pressure, okay, they say is this a water, right? It will act, okay, downward like this. Okay, but it will not like acting like on this part, no. It will only acting downward or upward like that. Okay, then we're not acting in this kind of that in this direction. Okay, so for this one, okay, this one means the 75, okay, 75 just times 10. That will be not like, no, there's sorry, there's an atmospheric pressure that acting on it because this is a open, right, open surface. So there is atmospheric pressure acting, but the only that not acting is the, you know, the where there's a gravity, right? So there's another force that pull the liquid here downward. So this is actually a mercury. So you pull downward like that. Okay, so for this one, only 75 times 10. This is the pressure, only the atmospheric pressure or the acting on it. So 75 times 10. Okay, but for this one, okay, since there's a gravity means there are force acting downward. Okay, there is a force acting downward. So for this part, there is a 75 plus 3. Okay, there will be the acting, a force acting on the mercury here. Okay, because of the gravity. So it pull it down. So 75 plus 3. 75 is from where? It's from atmospheric pressure. And the 3 is actually come from the mercury. So it acting on the mercury, so it will pull downward. So 75 plus 3. Okay, so the volume here that you need to find. Okay, so I explain again. Okay, for this one, okay, since the gravity is acting downward, right? So for this one, there is no way that it will go downward like that. Okay, because you put the test tube on this in this direction, in this kind of direction. So there will be no gravity that pull it down, right? So for this one, only atmospheric pressure, there is a 75, okay, times 10. Okay, but for this part, there is a certain force that pull it downward. Okay, so there is you should add 75 the atmospheric pressure with the length of the mercury here. So plus 3. So you will get 750 equals to 78 V2. So V2 is 750 divided by 78. So you will get 9.62. Okay. So remember for this one, there will be no like force of gravity acting on it. So only atmospheric pressure. So 75 times 10. Okay, and for this one, there will be another 4 setting on it. So 75 is the atmospheric pressure. Then you have to add the mercury here. The line is 3. Okay, and then after that, this is the volume, the new volume that you need to find. So 750 is equals to 78 times V2. So V2 is 750 divided by 78. You will get 9.62. Okay, is it okay? So let's say if I change in this direction, okay, so this is 3 cm. So what is the equation? If I pull it opposite way, so what is the direction now? So what is the equation? 75? Yes, 75 minus 3. Okay, because the force, the atmospheric pressure acting this way, and the gravity is acting downward. So you have, this is the opposite, right? Opposite direction. So you have to minus 75 minus 3. But for this one, it's the same. Okay, so it's the same, you have to plus 3. This one, because it's different direction. This one, the atmospheric pressure push it upward, and the gravity push it downward. So there is a change of direction here, right? Different direction. So 75 minus 3. And for this one, because the atmospheric pressure and also the gravity has the same direction, so you just add 75 plus 3. So you will get the answer. Right? So that's the answer for this one, 9.6. Okay, what happened for question number 4? So it says here figure A shows a J shape, okay, contains 6 centimeter cube of air trapped by mercury. So figure B shows more mercury is poured into the open tube of the J shape until the level differ by 150 cm. What is the volume of the trapped air? So the atmospheric pressure is 75. Try to answer this one. P1 V1 is equals to P2 V2. Two. 138.9. Rashmi got 2. Sajif also got 2. Janet also 2. Kritiga also 2. Weekend also 2. Okay, mostly got 2. Okay, so let's see for the diagram A, right? So what is the equation for diagram A? So you can see here at this part, right? The level of the mercury is same. Okay. So what happened here? You just 75. Okay, 75 is the atmospheric pressure, because you know when the in the open surface there will be atmospheric pressure acting on it. Okay. So pressure is 75. Okay, so what is the volume of air here? That is 6. Okay, so that is the first one. Okay, at the second part, okay, it add 100, it add the mercury, okay, it add the mercury until the level of difference is 150. Okay, so for this one, there are two pressure acting on it. Okay, the first one come from the atmospheric pressure, 75. Okay, and then another one is come from the mercury itself. Because this one is a water, right? It's not, it's a liquid. So you already know inside the liquid also, they got their own pressure. So 150. Okay, and then you need to find V here. Okay, so other than the atmospheric pressure, there is another pressure acting on it. That is the pressure of the mercury itself. Okay, so you mean you have to add two pressure here. So it's different here. This one is only atmospheric pressure. Okay, there is no pressure of mercury here. Okay, but this one they add more mercury. So there are now two pressure acting on it. The first one come from the atmospheric. The second one come from the mercury. So can you find for me V2? Are you still getting two as the answer? Okay, 75. Yes, good. Right, very good. So you got 2 cm. Okay, so I think I will stop until here first. Okay, so we still got two more laws, charge laws and precious laws. Okay, so next week we continue. Okay, on Monday. Right, and then if you have time, I will go to the wave. Right. Okay. Okay, so if anything, you can text me. Okay, and then I will sign to you the homework for the latent heat done, right? The guess law, I will not give you the homework, but I will give you something else, okay, for you to answer. Okay, so if anything, just text me. Remember, don't copy, do on your own. You don't know, leave it empty. Okay, all right. So I see you on next Monday. No, this Saturday. Okay, so this Saturday. All right. So take care, class. Okay. Have a nice day. Okay. Bye.
Thank you, teacher.
Bye.
Thank you, teacher.
Welcome. Bye.
Bye bye.
Thank you, teacher. Bye, teacher.
Bye.
Thank you, teacher.
Okay. Bye.